Assignment 9-7. Let's try and do it together as always. Try your best. Then press play. Let me help you, but not let me do it for you. And it says, hint, look at example number 1. So you can if you want to. I'm going to go through it. So again, this is all about practicing integration, everything really, but different integration techniques again. So what direction can I go? What's another integration technique we could use to integrate this? So the direction we're going to go is this. What's the derivative of the denominator? If I can take the derivative of the denominator, it would be 2x subtract 4. It's only 2x. So I'm going to go 2x subtract 4. Then I'm going to create a second integration. And I'm going to add 4. Because I know that negative 4 plus 4 is 0. These are the same. But I create two fractions so I can integrate it. All right. So the first one, the derivative of the denominator matches the numerator. That's just a logarithm. Done. The second one, well, I'm going to have to think about this one. So x squared subtract 4x plus 4 is factorable. That's negative 2 and negative 2. So x subtract 2 squared matches that. When I take the derivative of the base, oh, and it's to the negative 2. Thanks. So I think that through because it's in the denominator. The derivative of the base is 1, but I have a 4. So what I need to do is have that 4 in front. So 4 times 1, so now it matches. So our answer is going to be the natural logarithm of x squared subtract 4x plus 4. This is 4, and then what we're going to do is add 1 to the exponent and divide. Now when I divide by negative 1, it's really going to change this to minus 4. And you're done. If you can see the technique, it's not impossible to do. It's just being able to see it when it's there and then have confidence to go through with it. All right, we're integrating sine squared 2x subtract 2 cosine squared 2x. Now the hint is to separate this. Now, how is separating this going to help me in what direction I can go? So let's do what it says. Can we separate this into two fractions? So sine squared 2x over cosine squared 2x. There's 1. And then the second one is 2 over cosine squared 2x. All right, now what direction would we go? Sine over cosine is a trig identity formula. That's just tangent. So this is tangent squared. The second one is 1 over cosine squared. That's secant squared. So the reciprocal of cosine secant. And now what direction would I go? Well, tangent squared is a trig identity, right? So I can write that as a trig identity. So on the side here, I'm going to do that for you. So we know the trig identity may be sine squared plus cosine squared is equal to 1. If I divide everything by cosine squared, you can even see sine over cosine. That's tangent squared. Cosine squared divided by cosine squared is 1. And then 1 over cosine squared is secant squared. So I'm going to do a substitution. So I'm going to subtract 1 and then take out tangent squared. So tangent squared is really secant squared 2x subtract 1. The second one, we have an antiderivative rule for secant squared. So this one's ready to go. The derivative of 2x is 2, so the hook is right. And then the antiderivative of secant squared is tangent. So this is just tangent 2x. So that's nice and simple. Here, we also have something here. We could have also combined like terms, but whatever. So we'll combine like terms at the end. The antiderivative of secant squared 2x, I need a 2 because the derivative of 2x is 2, so I need a 1/2. So when I do this, it's 1/2 tangent 2x. The antiderivative of -1 is -1x. And then you could combine like terms here. So tangent 2x and tangent 2x, what's 1/2 take away 1? So it's -1/2 tangent 2x minus x plus c, if you combine like terms. I know, it's getting real, right? Number 3. We're going to practice until we can figure it out. We're going to integrate t squared, and it's times tangent t cubed dt. The derivative of tangent cubed is 3t squared, and that means I need a 1/3. So we're going to unhook this. We have 1/3. The rule for tangent is a logarithm. It's negative ln cosine, and then inside would be t cubed plus c. That's knowing your rules and seeing them. And again, it's practice and experience to be able to get through it. Number 4. In number 4, this is a definite integral. There's a hint to complete the square. Thank you for the hint. Will that help me? So I want to complete the square here. So you know what? On the side, I'm actually going to do it and then come back to the question. So 3 subtract x squared subtract 2x. So I'm going to do some work here to be able to complete the square so I can see it. So it's going to be 3 subtract, and I'm going to do parentheses because I can't complete the square if it's a negative with x squared. So I'm going to factor out the negative. So it's x squared plus 2x. The rule to complete the square is take the linear coefficient, which is b, and divide it by 2 and square it. So 2 divided by 2 is 1, and 1 squared, and there needs to be 1. Now, if I'm going to add 1, then I have to subtract 1 so it stays the same value. So I have x squared plus 2x plus 1. That's now a perfect square. If I take the negative times the negative, I actually get plus 1 at the end. So this number is actually now a 4. Did you see how I did that? So if I go negative times -1, that's plus 1, and 3 plus 1 is 4. This I'm going to factor, and it's x plus 1 squared. And now I'm going to go back to the question. So the integration of this is 1 over the square root of 4 subtract x plus 1 squared dx. So I put this here, and now I can see its arc sine. So for arc sine, u is the square root of x plus 1 squared, or just x plus 1. U prime, the derivative of this is 1. That's perfect. And then a is the square root of 4, which is 2. So this answer is going to be arc sine u over a. That's x plus 1 over 2. And we're going to integrate from -1 to 0. Start with the upper limit. So if I plug in the upper limit, that gives me 1/2. Subtract, plug in the lower limit. -1 plus 1 is 0. So at what angle is the y coordinate 1/2? That answer is pi over 6. At what angle is the y coordinate 0? That answer is 0. So altogether the answer is pi over 6. Number 5. And as always, if you need a break, you take a break, rewind and do it again, right? Go back in time and try it again and just think through each step with me. 2 over 9 plus x squared. So is this a logarithm or arctangent? So I'm fighting my chord. The derivative of 9 plus x squared is 2x. That is not like terms with the numerator, not a logarithm. So u is x, the derivative of x is 1, and a is the square root of 9, which is 3. So I'm going to write this the way it needs to be. It needs to be 1 over 9 plus x squared. So I need a 2 in front, so it stays the same. So my answer is going to start with 2. The formula for arctangent. Think about it. Press pause and try. Then press play. It's 1 over a, arctan, and then u over a. And that's it. There's it's an indefinite integral, so you just go plus c. Number 6. Practice, experience. That's what's going to happen. It's going to get us through the challenging times. You're not doing this alone, and you're not giving up. We have a fraction. It's e to the 2y subtract 1 squared over e to the y. And then what direction could I go here to help myself out? So whenever I see squaring, a direction I can go is I can FOIL it. So I can go e to the 2y subtract 1, e to the 2y subtract 1, like multiply it out. You get e to the 4y, you get minus 1 and minus 1, which is minus 2e to the 2y, and then negative 1 times negative 1 is 1. So you've expanded it. Next, there's a monomial in the denominator. So I'm going to write this as 3 different fractions. E to the 4y over e to the y. 2e to the 2y over e to the y. And then 1 over e to the y dy. All right. So these are the ones I'm going to integrate. I'm going to simplify if I can. So if the bases are the same, I'm dividing. I subtract the exponents. So that's e to the 3y. Again, if the bases are the same, subtract the exponents. So 2y subtract y is 1y. And then 1 over e to the y is just e to the negative y. So write it calculus friendly. So now we're getting closer to be able to do this. So the hook comes from the exponent. The derivative of 3y is 3. And then to unhook it, it's 1/3. So this is 1/3 e to the 3y. And we're off and running. So circle the hook and unhook it. The second one, the derivative of y is 1. So I need a 2 in front. So it's 2e to the y. And then the last one, the derivative of negative y is negative 1. So I need a negative in front. So it's subtract e to the negative y and then plus c. So it's the algebra, right, that we need to practice. That's okay. Everyone finds the algebra challenging. Everybody. So you're not alone. That the calculus is simpler and the algebra is really the stumbling block. Number 7, it says see example number 2. Maybe you should look back at example number 2 and then press play. All right. So the derivative of 1 subtract e to the 2y is negative e to the 2y times 2. So if I multiply by negative, or just e to the negative 2y, top and bottom, here, let's write it this way. So we're going to multiply it by e to the negative 2y, top and bottom. So if I do that, I get 2e to the negative 2y. And then I'm going to distribute. And e to the negative 2y times 1. And then if I multiply these together, I add the exponents. And then 2y plus 2y plus negative 2y is 0. So this is e to the 0, which is 1. So I did that multiplying so that this could now match. So the derivative of e to the negative 2y is e to the negative 2y. And then the hook should be negative 2, the double hook, so I need a negative in front. So the answer is negative ln e to the negative 2y subtract 1 plus c. Man, that just takes practice to see that. And once you see it, then you could do the work. Number 8. So again, we're integrating. Again, I see 1 over x, and I see ln x. So that's already an indicator to me. So when I see 1 over x and ln x, I think that's a connection. The derivative of ln x is 1 over x. So how can I use that? So if I write it as 1 over x and ln x to the negative a half, can I set this up to be able to integrate? So the derivative of ln x is 1 over x. Unhook it. Add 1 to the exponent. Divide, or the reciprocal, and you're done. Number 9. Always best to do it first and then press play. I'm not trying to go slow on the video. I'm trying to show you, and you can always rewind if I go too fast. For this one, they say, hey, split this into 2 fractions. So 3 over t squared plus 9. Negative 4t over t squared plus 9. So separate it into 2 fractions and then look at each one separately. The first one is arctangent. So u is the square root of t squared, which is t, and the derivative of t is 1, and a is the square root of 9, which is 3. So to set this up correctly, this needs to be 1 and then a 3 in front so that we can do it properly. So this is going to be 3 times 1 over a, and then arctan, and then u over a. And yeah, the 3's divide out, so it'd just be a 1 in front. How about the second one? The derivative of t squared plus 9 is 2t. So I'm going to write that down. So it needs to be 2t. So what do I need to multiply in front so these stay the same? This needs to be negative 2 so that they're the same. So if I simplify it, I get 1 arctangent t divided by 3. Negative 2 I start with, and then I unhook, and this is a logarithm. T squared plus 9, and don't forget the candy bars. Number 10. We have e to the x, a lot of e's here, e to the negative x, e to the x minus e to the negative x. All right, I feel like if I write this calculus friendly, it's going to be helpful. Or if I just understand the derivative of the bottom, maybe not calculus friendly, but the derivative of the denominator. So the derivative of e to the x is e to the x. The derivative of e to the negative x is e to the negative x times negative 1. Well, the negative and the negative makes it positive. This is perfect. And it's done. This is the logarithm of the denominator. Over. Number 11. I feel like I need to complete the square. Can you try that for me? I see a trinomial in the denominator. I see a constant in the numerator. This screams arctangent. Complete the square. Can you do it? Try it. Try to complete the square in the denominator, then press play. Negative 6 divided by 2 is negative 3. and negative 3 squared is 9. That's the number I need to complete the square. I'm going to use parentheses, and then I need to add 9 again so that it adds up to 18. So this is x subtract 3 squared. So when you factor this, what two numbers multiply to 9 and add to negative 6? And then still a plus 9 here. This should be dx somewhere. And now it's arctangent. So u is x subtract 3. The derivative of x subtract 3 is 1. And a is the square root of 9, which is 3. And then follow the formula. So the numerator needs to be a 1. So I need a 3 in front so it stays the same. So we're going to start with 3. 1 over a, arctangent, u over a, plus c. And that 3 times a third, you don't need that. It would just be arctangent x subtract 3 over 3. Number 12. And then we're going to practice derivatives. So for number 12, it says you have to do a u substitution. So we're going to let u equal the square root of x subtract 1. So I'm going to square both sides so that u squared is x minus 1. And then x would equal u squared plus 1. I need to know what x equals. I need to know what u equals. And I need to take the derivative, which would be 2u du. That's the derivative of x. So I need this, and I need all of it, right? I need x, and I need u. I need those three things. So I'm going to come back here and do a substitution. So obviously the square root of x subtract 1, that's just u. X, we said, was u squared plus 1. And then dx is 2u du. All right, we're going to put it together. So we have 2u squared over u squared plus 1 du. All right, now what do I do? So at this point, you're going to have to do long division because the power on top and the power on the bottom, they match. So u squared plus 1 divided into 2u squared. 2u squared divided by 1u squared is just 2. Distribute, subtract, and the remainder is negative 2. So back here, the answer is 2, and the remainder is minus 2 over u squared plus 1. This is arctangent. So on the side, it's going to be a little confusing because we're using u, but the square root of u squared is u, and the derivative of that is 1, and a is the square root of 1, which is 1. So look at the hook in the numerator. So we'll write it properly. The antiderivative of 2 is just 2u. So for the second one, it needs to be 1 over u squared plus 1. So we need a 2 in front. And now the rule is start with 2. And now it's 1 over a. Well, a is 1. So 1 over 1, if you like. Arctangent. And then u over a. U over 1. Now we're going to put it all together. So now I got to go back and know what does u equal again? So we'll put that back in there. So u is the square root of x minus 1. I was going to divide by 1, but I don't, and you have your answer. Man, that was awesome, right? Like that required you to do substitution, long division, arctangent, and then going back. Like that was a great question. That's worthwhile to go back and do it again from the beginning, one step at a time, and see where your skills are at. So that was a great question to see all the skills. All right, it's going to get easier now. Number 13, these are derivatives. So derivatives are easier, right, to work with. So for number 13, y equals ln arc tan 2x. And can you follow the rule? So the first rule is a logarithm. So the denominator is what I see. Arc tan 2x. The derivative of this is the numerator. Well, the derivative is a fraction. And so the derivative of 2x is the numerator. And then arctan, you go 1 plus 2x squared. Just like that. And if you wanted to, you would likely see this in multiple choice. It would probably be looking like this. That's how it would look. Number 14. Are you a rule follower? You probably are. If you're in calculus, then you kind of like rules and you follow the rules for the most part. So this is going to be the product rule. So the first, which is ln x, times the derivative of the second, which is a fraction. The derivative of 2x is 2. In the bottom is 1 plus, and then square. Plus the second, which is arc tangent 2x. And the derivative of the first is 1 over x, so we can just write that over x. And that's it. You could write this as 2 ln x over, and then this over that, if you wanted to. Always checking the answer key to make sure that I'm telling you the right thing. 14. Now let's look at number 15. In number 15, g at x equals ln arc sine x squared to the exponent 3. So I want to take the derivative here. There's multiple hooks here. So start with the 3. So 3 times 1 in front. It's just the power rule. Subtract 1 to the exponent times. So now take the derivative of a logarithm. So what you see is in the denominator. Then the derivative of that is the numerator. So the derivative of arc sine is also a fraction. So the derivative of x squared is the numerator of that. And then the bottom is the square root of 1 minus, and it's x squared squared. So 1 x to the 4th. And there's the rule. And that's it. You don't have to write it any better than that. All right, number 16. Oh, something therapeutic about that. Number 16. Oh, we still got one more here. And then there's some stories on the next page. All right, so this is going to be implicit with respect to t. So when I take derivative with y involved, I need a y prime. So the derivative of sine is cosine, and it has a hook to t. This is going to be the product rule. So the first times the derivative of the second, so e to the t, copy it, plus the second times the derivative of the first. And so now I just need to rearrange and divide. So we're going to subtract y times e to the t, and then the last step is to divide. Boop, there's your answer. And then divide to get y prime by itself. All right, turn the page. So for number 17, sketch graphs and show shaded areas representing the values of the following. So let's do that. So let's just start. Number 1, we're integrating from -2 to 2 the absolute value of x cubed plus x. Oops. Now the first thing I know is this is an odd function. Both exponents are odd. They're odd. So if it's an odd function around the origin from -2 to +2, then when you integrate, you just have to think through what that answer might be. Oh, is that right? So it says in my question that in the back of your book, so if you went way to the back of your book, like page 247, if you turn to that, you would actually see the graphs of that. So I'll put something there so I can go back to it. Oops. And so on. So the integral can be evaluated geometrically using areas of triangles so that no actual match to the integration of the description below. So this is all curvy. You're not going to use triangles. Absolute value is not even necessary for the given limits of integration. No, it's necessary because if you have negative here, it'll change to a positive number. The use of symmetry for the graph allows problem to be done using only one integral. That I like. So, and the integral can only be done using more than one integral. So the problem must be split into 2 or more. So the answer for number 17, definitely one is C. All right, we're just going to keep going through with this. Then in number 18, it says to set up the integrals that do not involve absolute value that could be integrated in problem and evaluate the integral using areas of triangles. So for number 18, I don't need this absolute value, so that means everything is positive. Now because it is an odd function, what's above and what's below are the same number. So if I graph this, let me just graph it for you. So if I graphed it, if I plugged in -2, I would get -8 subtract 2, which is -10. So if I went to -2 and -10, that would be there. If I did -1, that would give me 0. Because -1 and -1 is -2. If I plug in 0, the answer is 0. If I plug in +1, the answer is 2. If I plug in 2, the answer is 10. So it has symmetry, right? So this is what the graph would look like without absolute value, right? And so they match exactly. So if I look at this area here and look at this area here, those two areas are exactly the same. If there was no absolute value bars, the answer would be 0 because the area on top matches the area underneath. But with the absolute value bars, this actually gets reflected up. So that area is actually above. So it's not this area anymore. So that's what the area looks like. So in other words, if I take the right half and double it, you get the answer. So I'm going to go 2, and I'm only going to integrate from 0 to 2 and double the answer, and then I don't need the absolute value bars anymore. So absolute value bars require graphing, but if I can remove the bars this way, then I can just use integration techniques. So the antiderivative of this, you're going to add 1 and divide. You're going to add 1 and divide. And we're integrating from 0 to 2. So whatever my answer is, I'm going to double it at the end. So you're going to plug in 2 first. Then you're going to plug in 0. Now notice when you plug in 0, the answer is 0. So what is this answer? So this is 16 divided by 4. This is 4 divided by 2. So that's 6 times 2. So that area altogether, that area with absolute value, the answer is 12. I'm just checking in terms of the answer key. It doesn't matter. So the answer is 12 when you double it. Okay, how about number 18? The second one, number 2. It's kind of confusing with 17 and 18. So you are integrating from negative 2 to 2, and you have x squared plus 5x plus 6. Now, if I plug in, the only reason absolute value would be necessary if you get a negative answer that would then be changed. So if I plug in negative 2 here, you get negative 2 squared, which is 4, negative 10 plus 6. This answer is 0. As I plug in negative 1 and so on, all the answers are either 0 or positive from negative 2 to 2. So all values between negative 2 and positive 2 is either 0 or more. That means the bars aren't even necessary. So for number 2, the technique is B, that they're not even necessary. And so you would just integrate what you see. So for this one, it would be B, that the bars aren't necessary, because that gives you all positive answers. You don't need the bar to change a negative number to positive. And then the integration would be add 1 to the exponent and divide, add 1 to the exponent and divide, and then 6x. And then it would be from negative 2 to positive 2, and then you'd plug it in from there. Let me show you. So just, you plug in the upper limit, subtract the lower limit. Don't even simplify it. It's all good. Okay, let's look at example number 3, part 3. So for number 3, you're integrating from negative 2 to 2, x squared plus 5x minus 6. So now when you plug in negative 2, you do need the absolute value bars. Do I need to graph this? And is it going to be 2 different situations to set up? So let's graph it so I can have a better understanding of it. So I'm going to graph from negative 2 to positive 2. So if I plug in negative 2, I get 4 minus, this is negative 10, negative 16. So 4 minus 16, so it's negative 12. That's way down there. Negative 1 would give me positive 1, and negative 11, that's negative 10. 0 would give me negative 6. 1 would give me 0. And then positive 2 would give me 10, 14, 8 up here somewhere. So what I see here in terms of the graph, if I factor this, it would be plus 6 and minus 1, right? So negative 6 and positive 1. So this curves up kind of like this. The vertex is in the halfway in between negative 6 and 1. So that would be negative 2, right? No, negative 3. If I add them together, divide out, it's 2.5, negative 2.5. All right. So what matters is that this is part of a parabola. And if I'm reflecting up, this part that's underneath would then be reflected up. So this area here would be reflected up, and you'd find that. So we actually need to set up 2 integrals here. So one integral goes up to positive 1. So negative 2 to positive 1. And whatever that answer is, we need to make it a positive answer. So it's going to be a negative in front when we do that. So this answer is going to be negative. It's below, but I need to go make it multiply it by a negative so it changes to a positive. And then I'm integrating from 1 to 2 of the same thing. So that's what the setup would look like. All right. And if I read the question carefully, they say don't even evaluate. Like, just set this up so you can see it and then move on. And the only one to evaluate was actually the one using triangles. So if I look at example number 4, so I'm going to let that one go. What I did before was just great exercise. We're going to integrate negative 2 to positive 2, x plus 1 dx. And I said, how would you integrate that? So if I graph this from negative 2 to positive 2, so first of all, the vertex is at negative 1 because negative 1 plus 1 is 0. So at negative 1 is the vertex. If I plug in positive 1, you get 2. If I plug in 2, you get 3. So that's going to be an important number. So 1, 0 gives me 1, and then 2, then 3. So that point there is 2, 3. That will tell me the height of that triangle. So I want to find that area. And then at negative 2 plus 1 is negative 1, but the absolute value is positive 1. So here's the other triangle that you're going to do, and then you find the area of both. So for this one, there is no different integral setup. You just answer it, finding area of a triangle. So that's half the base times the height. That's this one. And this one, half the base, if you go across, is that 4? Half of 4. 3. Right? 1, 2, 3. Yeah. So the base is 3, and the height is 3. And there you go. So this would be 1/2 plus 9 over 2. So that's 8 over 2, which equals 4. Wait a second. 1 plus 9 is 10. 10 divided by 2, so the answer is 5. Silliness. All right. We're actually on to number 19. We did 17 and 18. We're on to 19. So a general solution. They'll give you a diffie-q. T times dy by dt minus 2y equals dy by dt. All right, and this is solve for y. So there you go. Combine like terms. So we're going to bring this together. So I'm going to subtract dy by dt. And then I'm going to, I'm going to add 2y. So I'm going to think of what direction to go here in terms of it. So I want to factor out a dy by dt. So I have t subtract 1. And now multiply by dt. And now we can start separating the variables. So I want the y's on one side and the t's on the other side. So I'm going to divide by 2y. And I'm going to divide by t minus 1. All right, how's that? Make sure that I'm okay. Oh, they kept the 2 on the other side. So instead of dividing by 2y, just divide by 2. Divide by y to make it easier. So keep 2 over here. So this 2 stays. Just divide by y to make it easier to go from. So now we can integrate this. So the integration of 1 over y is ln y. The integration of this, the derivative of t subtract 1 is 1. So I need a 2 in front, and it's a logarithm. And now I need to get y by itself. So it might be helpful to use a property here. So this is really t subtract 1 squared. When you square it, you don't need the absolute value bars anymore because it's always going to be positive. And then to write this, we're going to write it exponentially. Now, if I go e to the, we'll do this in 2 steps so you can see it. So you know this technique, e to there and then times e to the c to separate them. Recognize that e and ln, they cross out. So it's just t subtract 1 squared, and then we have e to the c in front. And then to remove the bars, it's plus or minus e to the c. And then we're going to replace it. So we're going to go plus or minus e to the c. That's equal that constant c2. So we have that. and put it all together. So that's the general equation. And then that was it, right? Because then they said just leave it at that. There's no point to then plug in. And you did it. Good job. All right, so number 19 is done. I know, you need to know a lot of stuff, right? And that's why we practice and have experience, so that whatever the question is, that we have experience in it, that we can do it. Number 20. The rate of growth of a bacteria is proportional to the number of bacteria present at any time t. So the rate of growth, so if y is the number of bacteria, the rate of growth would be this. And it says it's proportional to the number of bacteria present. So the number of bacteria present is y, so it'd be k times y. That's the diffie-q. So it's proportional to how many there are present at any time. So that's it right there. If I solve this diffie-q, you would get the, well, let's solve it. So it's dy divided by y, k times dt. Integrate both sides. That's ln y. And then the antiderivative of k is just kt plus c. Write it exponentially. And then to remove the bars, we're going to replace plus or minus e to the c with c2. And really, this is just PERT, P times E to the RT. Then in the question says, there were 2,000 bacteria present, so 2,000 present, 3 days after the introduction. So that would mean that T is equal to 3. And then I want to solve it. So this is a calculator question, so we're going to take our calculator out, and we're going to solve. Oh, what else do we know? 5,000 were present 2 days later. So you have 5,000 were present 2 days later. And then I want to solve it. So I'm trying to think what's the best way to then solve it like this. So we're going to get our calculator out. We really have two equations, two unknowns. That'd be a good thing to know on our calculator to know how to do. So if I press menu and go to algebra, I can solve a system by pressing number 7. These are not linear equations, so they're just equations. So number 1. And I'm just going to use x and y instead of, well, I can use c and if you want to. There's two equations. And so I'm going to use c for the constant, comma, the other one is k. Why not? And then press OK. So my first equation is 2,000 equals c, and then it's e to the exponent 3k. And then the second equation is 5,000 equals, and again it's c, and it's e to the 5k. Oops. Wrong, e. This e. Make sure you don't use the e on the bottom of the keyboard. E on the left. E to the x. So e to the 5k. All right, what do we get? Let's see how this works. So I got C is 505.96, so on. So if I round it, bacteria needs to be a whole number. And then I have a number for the rate, 0.45 and so on. Awesome. So the question is, find the growth rate of the culture. So that answer is 0.458. That's the growth rate. Part B, as a percent, or just the growth rate? Just the growth rate. Part B, the number of bacteria initially introduced into the culture. So now I have that ability. So I'm going to write this equation down. I now know what K is. So I'm not going to use the rounded answer. So it's 0.458. So I'm going to take one of the values. So 2000 was present when T is 3, right? So I'm going to solve that equation, but not use the rounded answer. So how do I solve that equation? So to solve that equation, we're going to go menu, algebra. We're going to solve, and the equation we're going to solve is 2000 equals, I'm looking for C, so I'll just go C, E, and then we need to copy paste. So I need this number up here. So I'm going to double click that one. I'm going to go Control C, and then I'm going to go back down here and go Control V and paste that whole thing in. That's K, and that's times 3, and then go comma C. So how many were there initially? And I got the answer 506. Actually, I knew that at the beginning. Why have I did all that work, and I actually knew the answer, what C was, right here. It's the same answer. Why did I do all that? I think my brain starting to melt. It's 506, right? We already knew what C equaled because I'd solved a system, which made it way easier than having to do everything I did. So, the answer to this for B was just that the initial population was 506 bacteria. That's what C equaled. We knew that from the beginning. So when we solved our system, we solved for how many were there originally and the growth rate. It was cool. It was like a great system, an easy way to do it. Then I made it longer. And then C says estimate the number of bacteria after 12 days. Well, now we need to use this. So we have a 506, and then it's E. I got a little cute little fly here. And it's after how many days? 12 days. And then use your calculator, and there you go. So I'm going to do that too. Type it in. So that's 506, and then it's E, and then I'm going to paste times 12. So this is what it looks like for me. And I get that many bacteria, 123,535. After 12 days. All right, 21. We got 2 questions left. Let's get them done. So, number 21, a small dog kennel with 8 individual rectangular holding pens. So, I'm going to draw that. I see it. So, there's 1, there's 2, there's 3, there's 4, there's 5. How many is there? There's 8. There's 6, 7, 8. Okay, all right? So there they are. There's all 8 across. They're all of equal size. And it's to be constructed using 144 feet of chain link. So I know that's the perimeter. So these are all the same size. One side of the kennel is to be placed against a building. So I don't need this right here. I don't need chain link for. So if I could describe the perimeter with chain link, how many X's do I need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 is what I got. So 17 X's. Is that going to be the perimeter? Oh, they have X and Y. So one, it says, oh, they're rectangles, so they're not squares. So that's a Y. So if I think of like how many x's there are, 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. And 1, 2, 3, 4, 5, 6, 7, 8 y's. So 9x and 8y. That would describe the perimeter, and we know the perimeter is 144. Okay, if we know something, that's secondary. Area is what I'm looking for. So it says find the dimensions that produce a maximum area for each pen. So the entire area here would be length times width. So that'd be x times how many y's across. So it's x times 8y would give me the area. Length times width. Oh, they said don't even worry about the whole thing because all of them are an equal rectangle. I can just go x times y and just use one of them and find the maximum one for each pen individually. So x times y is one pen. Use the perimeter, get y by itself. So subtract 9x and divide by 8. 8 goes into 144 evenly. That number is 18. And then you have 9 over 8x. So you can simplify that a little bit. So come back here. Instead of y, put in 18 minus 9 over 8x. And then we're going to multiply it. So that's 18x minus 9 over 8x squared. And now we have something we can take the derivative of. So if we're maximizing something, take the derivative of it. That's 18. 2 times 9, or 2 divided. That's 2 times 9 is 18 over 8. Subtract 1 to the exponent and make it equal to 0. So we can reduce that down. That's 9 over 4. So we're going to add 9 over 4. Multiply by the reciprocal. And I get 9 goes into 18 twice. So 2 times 4. I get 8. X is equal to 8. So if I think about it, now here, this answer can't be bigger than 18. So if I solve this, if I made it equal to 0 and solved it, that would actually tell me the domain restriction. So if I multiply by the reciprocal, I get 16. So that's the domain restriction. If I look in the derivative, if I plug in a number between 0 and 8, like 1, the answer is positive. And if I plug in a number bigger than 8, the answer is negative. This is a maximum. So we know x is 8, y is 144, subtract 9 times 8, divided by 8. So we know an equation for y right here. So plug 8 in and then solve it. So 144 take away 72. What's 144 take? I can't even think right now. 144 take away 72. Can you do that? That's 72 divided by 8. Anyway, the whole answer is 9. Probably a better way to get there. So 8 feet by 9 feet is the maximum area for each pen. And we did it. All right, one left. Number 22. Let's do this. And you can see the questions we need to practice more and the ones we need to still be more confident with. Here's the last of 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 this book. Number 22 at the very end. Here we go. A block of ice is exposed to heat in such a way that the block maintains a similar shape as it melts. The block of ice is initially 2 by 2 by 3, shown at the right. If the rate of change in the width of the ice is negative a third, because it's getting smaller, feet per hour, the rate of change in the volume of the block of ice when the width is 1 feet. So the volume of this block is length times width times height. All of it is changing with respect to time. We know that the width over time is changing at that rate. we know it's 2 by 2 by 3, and it's similar. So that creates like a ratio. So if it's 2 by 2, that means the width equals the height. So that's helpful. And then it says the length is, so twice the other way. So if I go 3 over 2, so 3 over 2 times the width, I get the length. So I'm given it's 2 by 2 by 3, and that as it melts, it stays in the same ratio to each other. So if I take the width at any time, if I multiply it times 3 over 2, I would get the length of whatever it is. So I need to know that relationship. So I'm going to change this all in terms of width. So the length is 3/2 the width, then the width, and the height and the width are the same number. So put this together, you get 3/2 W cubed. I know. The hardest part was this part, to see the relationship between the width and the length as it melts. Now we're going to take the derivative with respect to time. So 3 times that is 9 over 2. And then with respect to time. And now it says when the width is 1 feet. So dv by dt, the width is 1. We know that dw by dt is negative 1/3. So put that all together, and you get negative 9 over 6. And it's going to be inches cubed per hour, feet cubed per hour. You could also write that answer as negative 3 over 2 feet cubed per hour. And now the last question. What's the amount of time it will take for the block of ice to completely melt? That means the volume would be 0. So the volume is 0 when the width is 0. So dw, the rate it's going, is negative 1/3 feet per hour. So the volume's going to be 0 completely melted when the width is 0 completely melted. We know the rate it's melting at, negative 1/3 feet per hour. So that means that every 3 hours, 1 foot is melting. That's what it means. So every 3 hours, 1 foot is melting. That's how you could write it. The original one was 2 feet wide. So if the rate is every 3 hours, 1 foot is melting, then you could see the answer is 6 hours to melt. Because we have 2 feet. So 2 would take 6 hours. So every 3 hours, 1 foot, we have 2 feet wide. Put it together, and it would take 6 hours to melt. We got through the whole book. I am so proud of you, and you're working with me. Some questions are challenging. You might have to go through it again, ask questions, clarify a whole bit, but you went through it all. You did all the questions. You did all the assignments, and I'm really proud of you. Mr. G Math, over and out. Until next time. And I went over an hour by 4 minutes. I could have been closer to an hour.